everyone, this is Borotan Z. I plan to share tips and information on how to enjoy creating 3D CG for those who are thinking of starting 3D CG or making it their career. This time, we're going to add bones to the low-polygon character we created last time so that it can be animated. In Blender, we use a system called armature to add bones. By creating a bone structure with this armature, parenting it to the character, and setting weights on the model, you can freely move the character. While it's certainly fine to insert this armature from scratch, Blender comes standard with a system called Rigify that makes rigging bipedal characters much easier. We will use that to make the character movable. If you can successfully assemble the rig, it's like preparing to breathe life into the character. Now, let's get started. First, activate Rigify in the Properties add-ons. If you search for a rig, you should find it quickly. Under the Add Armature menu, there is a human meta rig, so we will add that. Once added, we will adjust the size so it fits the character model as the skeleton. In the Armature properties, check In Front in the viewport display. This will display the bones in front of the model. Select the meta rig and use the scale to match the size of the character. I think it's a good idea to use the hip position and the collarbone position as references. After matching the size, apply All Transforms, Object, Apply All Transforms to set the scale back to 1. Borotan Z-Man was created in a straight standing posture to match the ratio. But when adding bones to a character, it is common to use either a T-pose or an A-pose. There is the T-pose, where the arms are extended horizontally at 90 degrees, and the A-pose, where the arms are lowered diagonally. This time, we will match the A-pose, which is the shape of the meta rig. If you want to match the T-pose, make it a T. Select the model, go into Edit mode, select the arm polygons, and rotate the arms to align with the bones. If symmetry doesn't work well, you might want to rotate one arm at a time. Align the 3D cursor with the arm bone position, set the pivot point to the 3D cursor, and rotate. For the opposite side, enter a negative value for the X position of the cursor. Rotate using the same rotation value. Move the joints of the meta rig to the positions of the character's joints. Sometimes the bones are not connected, so select both bones and move them. Once you have finished positioning the bones, open the Rigify panel in the Data properties of the meta rig. Update the facial rig. After that, press the Generate Rig button. This will generate the rig. You can regenerate the rig by readjusting the meta rig. But for now, hide the meta rig. Now that the bones and the rig are created, the next step is to parent the model to the bones and perform skinning. Select the model, then select the rig and choose Automatic Weights under Parent Armature Deform. The rig and the model are skinned and the rig can now be used to move the character. To move the rig, switch to Pose Mode. Select the hand rig and try moving it. The arm follows the rig. By using Rigify, A rig that can easily create human movements is generated automatically. There are many other rig tools and add-ons, but Rigify, which is included standard in Blender, is sufficiently convenient. I recommend starting here first. If you move the hips, you can see that the legs are also moving with the rig, just like a human. The rig is a mechanism designed to create movements that are as natural and human-like as possible by moving the controllers. By adding animation to this rig, you can easily express human movements. If you move the hip position beyond the length of the arms or legs, they will stretch. But if you select these arm and leg rigs and set IK stretch to 0, they will no longer stretch beyond their length. You can use this conveniently depending on the situation, such as creating cartoon-like movements or exaggerating hand sizes. So try switching it on and off. If you move the character around, you might find some unnatural bends. For a standard model like this, the weights are applied quite cleanly automatically. But since there are still some slightly unnatural shapes, in those cases, adjust the skin weights. Go into Edit mode and select the vertices you want to correct. If you want to adjust the weights while maintaining a pose, check the Edit mode and Cage options in the Armature modifier. The weights currently assigned are displayed in the Vertex Weights section of the Sidebar's Item tab. Set the bone you want to have 100% weight to 1 and the others to 0. If you want to maintain the original shape as much as possible, use a value close to 1. If you want other bones to influence it, set the degree of influence numerically. Since the total value needs to be 1, press Normalize to ensure the total value is 1. The value you just set is only applied to the initially selected vertex. So press the Paste button next to it to paste the same value to the other selected vertices. After adjusting the weight on one side, select the vertices on the opposite side in Edit mode and apply Mesh, Weights, Mirror. In the bottom left options, check All Groups and Topology Mirror. The adjusted weights will be reflected on the opposite side. Once all settings are done, select all vertices and press Mesh, Weights, Normalize All in the menu. Now that the skinning has been adjusted, let's try setting various poses for this character. What did you think? You were able to move the character freely, right? Using a rig, you can easily create any pose. Next, let's add animation to the character. Let's create a walk animation. You can find many images showing pose breakdowns for walk animations by searching online, so download one you like. Set up a side view and drag and drop the reference image. Now, we will use the rig to sequentially set the poses according to the reference. Below the Blender layout, there is a timeline that displays the frame number. When creating an animation, first set how many frames are displayed per second. Set the FPS in the output properties. 24 FPS is common for movies, 29.97 FPS for TV, and 30 FPS is typical for computers. We will set it to 30 FPS this time. 30 frames on the timeline will result in 1 second of animation. Insert a keyframe using Insert Key for the pose animation. The key will appear on the timeline. Advance the frame by 5 frames and set the next pose. Select the entire rig again and insert a keyframe. Repeat this process to set keys from pose to pose. Think of animation as displaying a sequence of poses rapidly. The framing rate for Japanese TV anime is 6 to 8 frames per second. Since live-action movies have a frame rate of 24 frames, limited animation is often produced by changing frames every 4 or 3 frames. Thinking about CG in terms of anime frames makes it easier to understand and work with. CG interpolates the spaces, so it's essentially moving in every frame. After setting poses 1 through 4 from the reference image, pose 5 and on will be reversed poses. Blender has a convenient feature called the Pose Library. So we will try using it. Search for Pose in the Preferences add-ons and confirm that the Pose Library is enabled. Enable the Asset shelf in the View menu to display the shelf below the 3D view. Displaying the sidebar to the right of the timeline at the bottom will show the Create Pose Asset tool. If you register a pose here, you can easily switch to that pose and even flip it. Since we want to use the flipping function, we will register the walk poses. Press the Create Pose Asset button while aligned with the pose frame, and the pose will be registered in the shelf. However, registering the pose might change the current action. Therefore, change the timeline to the dope sheet and use the action editor to change it back to the original action. Similarly, register the poses from the other frames in the library. Once registration is complete, advance 5 frames from the last frame and click Pose 1. Once the pose is applied, check the Apply Flipped in the bottom left. Since it flips left and right, insert a keyframe. Similarly, advance 5 frames for the other poses, flip them, and insert keys. We easily created the flipped movement. Since the walk animation is complete, set the end frame to the final frame and play it back in a loop. The spaces between the poses are interpolated, resulting in a smooth walk animation. If you think the movement looks strange, try correcting the pose. Since it's difficult to control every frame from the start, we control it using poses. Interpolation between a good pose and another good pose should turn out beautifully. If you still want to adjust the movement, try adding poses between existing keys. Also, if you want to adjust the tempo, slowness, or quickness of the movement, adjust the frame position of the keys. It feels like you can create anything if you approach manual animation this way. Although it is possible to adjust using F-curves or make fine adjustments, It's simpler to think of it the same way as drawing animation, and you'll find it more enjoyable if you focus on the poses and how you present them. What did you think? If you can do this much, it feels like you can create anything, right? Now, let's fly through the infinite world of imagination. In the next video, I plan to add movement to this character using motion capture. See you in the next video.